Welcome to a lesson on converting between spherical and rectangular equations. In the video on spherical coordinates, we saw these equations that can be used to convert between spherical and rectangular coordinates, and we can use the same equation to do the conversions between spherical and rectangular equations. So let's go ahead and take a look at our first example. Here we're given the rectangular equation x equals 2, and we want to convert this to a spherical equation. So remember, an equation in spherical form must only contain rho, theta, and phi, and it cannot contain x, y, or z. So if we take a look at these equations, we can replace x with rho, sine phi, cosine theta. Let's go ahead and do that. We'd have rho sine phi cosine theta equals 2. And now this is a spherical equation, but normally we want to solve these equations for rho if possible. So let's divide both sides by sine phi cosine theta. So we have rho equals 2 over sine phi cosine theta. But remember, 1 over sine phi would be the same as cosecant phi. So we can write this as 2 cosecant phi. And 1 over cosine theta would be the same as secant theta. In this example, we want to convert x squared plus y squared minus z squared equals 0 into a spherical equation. So using these equations here, we need to eliminate x, y, and z from the equation. Now there's no obvious substitution here. It would be nice if this was plus z squared, then we could perform a substitution here using rho squared. So what we'll do here is move the z squared term to the right side. And now if we add a z squared to both sides, we would have x squared plus y squared plus z squared equals 2z squared. And that's helpful because now we can replace the left side with rho squared. And now we only have to deal with this z squared. But there is an equation here that says z is equal to rho cosine phi. So we would have 2 times rho cosine phi, and this would be squared. Now let's see if we can clean this up. We would have rho squared equals 2 rho squared cosine squared phi. Now if we divide both sides by rho squared, this simplifies to 1, this simplifies to 1. So we're left with 1 equals 2 cosine squared phi. Now let's divide both sides by 2. So now we have cosine squared phi is equal to 1/2. Now let's go ahead and take the square root of both sides. So the square root of 1/2 would be the same as the square root of 1, which would be 1, over the square root of 2 must equal the square root of cosine squared phi would be cosine phi. So cosine phi would be equal to arc cosine of 1 over the square root of 2. So if we can determine what this angle would be, we'd have a very simple equation in spherical coordinates where phi is equal to some angle. And this ratio should look familiar. It occurs in a 45, 45, 90 right triangle. So the cosine of this angle here would be 1 over the square root of 2. So phi is actually 45 degrees, or phi is equal to pi over 4 radians. And that would be our spherical equation. Phi is equal to pi over 4 radians. So this one was quite a bit of work and it's a little bit messy here. Sorry about that. But it does come out to phi equals pi over 4. Now let's take a look at a couple equations given in spherical form where we want to convert them to rectangular form. So this one's almost like the other one, but this one says theta is equal to pi over 4. So if we use this equation here, where we can replace theta with pi over 4, we have an equation that only contains y and x. So let's go ahead and try that. We would have tangent theta, which is equal to pi over 4. So tangent pi over 4 is equal to y over x. Well, going back to our previous example, tangent of pi over 4 would just be 1 over 1, or just 1. But let's go ahead and write it as 1 over 1. So we have 1 over 1 is equal to y over x. Now we have a proportion, we can just cross multiply. So y times 1 would be y equals 1 times x, or x. So the equation y equals x graphed in the xyz coordinate system would produce this plane here. And this would be the equation in rectangular form. Let's go and take a look at one more. Here we have rho equals 2 cosine phi. Here we want to convert the equation rho equals 2 cosine phi into rectangular form. If we take a look at this equation here, if we solve this for cosine phi, we'd have cosine phi equals z divided by rho. Let's go ahead and perform that substitution here. So we have rho equals 2 times z divided by rho. Well, that would give us rho equals 2z divided by rho. If we put rho over 1 and now cross multiply, we'd have rho squared equals 2z. Let's go ahead and do that. Now the reason that's helpful is we have an equation that relates rho squared to x, y, and z. So using this equation here, we can rewrite this as x squared plus y squared plus z squared equals 2z. Let's go and set this equal to 0. And now we have a rectangular equation for the spherical equation rho equals 2 cosine phi. Now there's one more thing we could do. We could complete the square on the z part. Let's go ahead and do that. Half of negative 2 squared would be positive 1. So we'd have z squared minus 2z. If we add 1 on the left side, we do have to add 1 on the right side. And now we can see this would be a sphere. Where the center is at 0, 0, 1, and the radius would be equal to 1. Okay, that's going to do it for this video.